Hi, it's Dr. Z. In this video, I will introduce probability. By the end of this video, you'll be able to describe the relationship between proportion and probability, as well as to calculate probability using two methods. Please feel free to pause the video at any time to take notes. What is probability? The chance of winning the lottery? The odds that it will rain today? The likelihood that you will win at the poker table? In its simplest definition, probability involves the chance that a given event will occur. Students often think that calculating probability is scary. In this video, I will show you how calculating probability is as simple as using proportion or using the normal distribution. Probability is not scary, my friends. In fact, you've already heard about probability. Last week you learned about proportion. Proportion is just referring to a portion of something larger. For example, a portion is 2 slices of pizza out of a whole pizza that contains 8 slices. So let's review proportion. In statistical notation, proportion is the lowercase italicized p. The definition of proportion involves measuring a part of the whole. In the pizza example, the frequency f is 2 slices and the whole n is 8. As such, the formula for proportion is p equals f over n. Proportions can be reported as fractions, decimals, or percentages. In the pizza example, p equals 2 over 8, or 0.25, or 25%. So let's introduce probability. In statistical notation, probability is also lowercase italicized p. Why does probability have the same notation as proportion? The answer is because probability and proportion are the same thing. Probability is just a fancy way of saying proportion. Heck, the definition of probability even uses the word proportion. As such, the formula for probability looks very similar to proportion. In the probability formula, possible outcomes is the frequency of a specific outcome, and all outcomes is the total number of outcomes. Probability is reported primarily in decimals and sometimes in percentages. When calculating probability, there is unique notation. When we write p parentheses a, it means the probability of selecting A. You will place in the parentheses the item or event for which you want to calculate probability. I will provide several examples later in this video to better explain this unique notation. There are 2 ways to calculate probability. The first method involves using the formula from the previous slide. Step 1 is to determine the possible outcomes for selecting A. Step 2 is to determine all of the possible outcomes. And step 3 is to use the following formula. This formula indicates that the probability of selecting A equals the possible outcomes classified as A divided by all the outcomes. Now that we've introduced probability, are you ready to practice your new knowledge? I have 3 examples for you to review. Using a deck of cards, you will calculate probability for the following questions. Before we begin, let's review what we know about a deck of cards. First, there are 4 suits: diamonds, clubs, hearts, and spades. Second, each suit consists of 13 cards. And finally, a deck of cards consists of 52 total cards. Here are our 3 questions. I encourage you to pause the video here and attempt this question on your own before viewing the answer. Question 1 is asking, what is the probability of selecting the king of hearts from the deck of cards? Well, there's only one king of hearts in a deck of 52 cards, therefore the probability equals 1 over 52. When reporting the probability as a decimal, please round to 2 decimal places. Question 2 is asking, what is the probability of selecting a king from the deck of cards? There are 4 kings in a deck of 52 cards. Therefore, probability equals 4 over 52, or 0.08. Question 3 is asking, what is the probability of selecting a heart from the deck of cards? There are 13 hearts in a deck of 52 cards. Therefore, probability equals 13 over 52, or 0.25. Now, before we discuss the second method of calculating probability, we need a brief history lesson. Abraham de Moivre was a French mathematician in the early 1700s. He became a well-known statistician who pioneered the theory of probability when he published the Doctrine of Chance in 1718 while living in England. Unfortunately, because he was a French foreigner living in England, Moivre was unable to obtain any academic positions at universities. As such, Moivre was a private tutor of mathematics and served as a consultant to gamblers. Gamblers asked him to calculate the odds, or probability of winning, so he practiced by flipping coins first. He found that the more coin flips, the more the graph, or the distribution, looked like a smooth curve. Moivre found the mathematical formula for the normal distribution. In other words, Moivre calculated all the probabilities under the normal curve. The second method of calculating probability uses the normal distribution. Thanks to the work of Moivre, a normal distribution is a probability distribution. They are the same thing because Moivre calculated all the possible outcomes, or the probabilities in percentages, which created the normal distribution. Now, remember that statistical notation for proportion is P, and that proportions can be reported in percentages. Well, statistical notation for probability is also P, and probability can be also reported in percentages. In other words, my friend, if you replace the word probability with the word percentage, you can use the normal distribution to find the answer. I will provide an example later in this video to better explain the situation. The second method of calculating probability uses the normal distribution. Because a normal distribution is a probability distribution, you will use the same steps as finding percentage for a specific z-score. You learned how to do this either during in-person class or through the online lecture video on calculating z-scores. Now that we've explained the relationship between probability and the normal distribution, are you ready to practice your new knowledge? I have one example for you to review. IQ scores form a normal distribution with a mean of 100 and a standard deviation of 15. You will calculate probability for the following question. What is the probability of randomly selecting someone with an IQ score greater than 120? In other words, what is the percentage of people with an IQ score greater than 120? Now that we're using percentage, we can use the same steps as finding percentage for a specific z-score, as discussed earlier. I encourage you to pause the video here and attempt this question on your own before viewing the answer. When doing word problems, I encourage students to write out the key values first, rewriting your mean and your SD, and here our X is 120 because an IQ score score is X, and probability is P, or percentage. So let's get started. Step 1 is to calculate the z-score that corresponds to X equals 120 using the z-score formula. The answer is a z-score of plus 1.33. Step 2 is to draw the normal distribution and to shade the area in the tail because we're interested in the people who have higher IQs than 120. This means we will look for our answers in the column labeled percentage in tail. Step 3 is to use the normal curve table. So let's look at that normal curve table. You will go to the z column and scroll down till you find your z of 1.33, and then scroll over to where the percentage in tail column is to find the corresponding percentage. This answer here is your final answer. The answer is 9.18%. In other words, there's a 9.18% probability of randomly selecting someone with an IQ score greater than 120. In summary, probability involves the chance that a given event will occur. We can use proportion and the normal distribution to calculate probability. The concept of probability serves as a transition into inferential statistics and is an important Lego building block in understanding statistics.